Hey guys, it's me, Mr. Roundy, and I am ready to go over with you Chapter 5, Lesson 3. As you can see on my screen here, I've got some vocabulary that we need to cover. Now, Chapter 5, Lesson 3 is all about properties of operations, okay? And if you remember, operations are add, subtract, multiply, and divide. So pretty simple, basic things, right? Well, the first vocab term that I want to go over is commutative property. And this is something that you've learned before. This is just review. Commutative property is the order in which numbers are added or multiplied, does not change the value of the expression. So if you'll look at these two expressions I've got down here, I've got 5 plus 4 equals 4 plus 5. Now the equals is just there to show that these two things are the same. So I've got one expression, 5 plus 4, and I've got another expression, 4 plus 5. And they are equal to each other. Doesn't matter if I put the 4 first or the 5 first, I get the same answer. My other example is x times y is the same as y times x. So either way I write that expression, I still get the same answer, have the same value. Okay, our second term is associative property. Associative property is the way in which numbers are grouped when they are added or multiplied, does not change the value of the expression. For example, in my first expression, I have a plus parentheses b plus c is the same as doing the parentheses around the a and the b. So on the first one, I have the parentheses around b and c, and on the second one, I have them around a and b. And it doesn't matter which way they're grouped, I'm going to get the same answer. Parentheses just tell me which part to do first. So on the first one, it's telling me to add the b and the c first. On the second one, it's telling me to add the a and the b first. Doesn't matter which way I do it, I still get the same answer. Same thing for multiplication. If I do 5 times 4 first and then times 3, or if I do 3 times 5 first and then times it by 4, I'm still going to get the same answer. Now, associative and commutative property do not work with subtraction or with division. They only work when you're adding or when you're multiplying. The next property that we want to look at is something called additive identity. And it means when 0 is added to any number, the number stays the same. That's why we call it an additive identity. Identity means that the number doesn't change, even though we're adding something. So if I do x plus 0, I just get x. Or 0 plus 5, I still just get 5. Next, we have the multiplicative identity. Multiplicative identity is when any number is multiplied by 1, the number stays the same. For example, I've got 1 times x, that just gets me x. Or 6 times 1, that just gets me 6. That's why we never write a 1 in front of the variable x or any variable for that matter. Okay, I don't write number 1 in front of variables because 1 times a variable just gets me that variable. 1 times anything gets me that thing it was multiplied by. Last one. We've got the multiplicative property of 0. When any number is multiplied by 0, the product or the answer is 0. So if I do 42 times 0, I get 0. If I do 0 times y, I get 0. Doesn't matter what number was going to be substituted in for y, it's still going to get 0 because anything times 0 is 0. So those are our properties that we've covered. We've got commutative, associative, additive, multiplicative, and multiplicative property of 0. Now, we're going to do a little bit of practice with these. So, this whole chapter really is focusing on expressions and being able to manipulate or change expressions but have them stay equal or the same. For example, I've got 3a here. Now, I could manipulate this particular one using the commutative property by switching the order that the 3 and the a are in. And I could say a plus 3 is the same as 3 plus a. Doesn't matter which way I do it because of the commutative property. It says that I can switch those, the order that they're being added in, and it still gets me the same answer. So if I wanted to manipulate this one, I could change it to a plus 3, and that's the same thing. They're equal or the same. Another example is if I had 3 times x, and I wanted to manipulate that, I could say x times 3. Those two expressions are the same. Okay, this whole chapter is all about being able to manipulate and change expressions as needed, but have them stay the same or equal to what they were before. So let's look at a problem here. Let's say I've got 42 plus x plus y. I'm saying that this one is equal to 42 plus y plus x. Now, if I'm looking at this, what property has been applied on this particular example? I'll give you a second to think about it. Okay, so if you noticed, the thing that happened here is our x and our y got switched. And when we trade places or move the order that things are in, then we have commutative property. Here we've got another example. We've got 3x plus 0 is equal to 3x. So which property are we dealing with here? That's right, we're adding 0. So this means we've got the additive identity. When I added 0 to 3x, it still just is 3x. Here's another example problem. We've got parentheses around our 3 times m times 2, and we say that this is equal to 2 times parentheses 3 times m. What property is being applied here? And I bet a few of you might get tricked on this one. If we look at the problem, we see that the thing that was actually happening, the parentheses didn't move. So if you said associative, you're wrong, because the parentheses didn't change where they were at. And when associative happens, we're changing how the numbers are grouped. In this case, that means we would have had to be moving the parentheses around the 2 and the 3, or maybe around the m and the 2, and that would have been changing it. However, what happened here is we had the 3 times m and the 2 trade places when we came to this side. And because we were changing the order of the terms, or the things that were being multiplied, that means we're dealing with commutative property, because we were changing the order that they were being multiplied in. Here's one more example of the properties being applied. Which property is happening in this problem? If you're looking at it, you'll notice that the numbers and variables didn't change places at all. They stayed in the same order in both sides of this equation, or where their equal sign was separating. So we have 4 plus a plus 6, 4 plus a plus 6. Those didn't change. However, where the parentheses are did change, which means that this is a case of associative property. Now let's look at a word problem. So I see here that Alana wants to buy a sweater that costs $38, sunglasses that cost $14, a pair of jeans that cost $22, and a t-shirt that costs $16. And it says to use mental math to find the cost before tax. Now with this problem, I can actually use one of my math properties to help me solve it. Now normally doing this, and I'm going to show you my board even though we wouldn't typically do this, okay? I believe our first number was 38, our second one was 14, I believe, then we had 22, and we had 16, because that's what we do to find this. Let's double check our numbers. We got 38, 14, 22, and 16. Good, we got them right. Now, if it wants us to do mental math, that means to solve this problem without adding it and writing it down like I just did. And we would actually use commutative property to help us solve this problem. Because instead of trying to add them in the order that they came in the problem, I'm actually going to move them around so that they're a little easier to add and group them together as well. So 38 and 14 maybe aren't so easy to add in our head. However, 38 and 22 are a little bit easier, because if I do 38 plus 22, that 2 and 8 I know makes 10. So there's 40 plus another 20 is 60. So I can add that one up in my head, or hopefully I can. Okay, I can also group my 14 and 16 together. So I've used commutative and associative property to kind of regroup this problem. I would be doing this in my head without writing it down, but I'm actually using commutative and associative property as I do it. Now 14 plus 16 is going to get me 30, and 60 plus 30 is going to get me 90. And there I've got the answer to how much money this person spent. So understanding commutative and associative property, also additive identity, multiplicative identity, and multiplicative property of 0, they can help me solve problems more quickly if I can use them to help manipulate and change the order that things are in. And so that's what we're trying to cover here with this lesson. We want to make sure that we can manipulate an expression and have it still be equal to what it was before. Next, what we're going to do is we're going to take these expressions that I've got right here, or this expression that I've got right here, 7 plus g plus 5, and we are going to simplify the expression. And what that means is we're going to try and make this as simple as it possibly can be with as few terms and pieces as possible. So the first thing I notice is that 7 plus g have been grouped together, but I can't add 7 and g together because one's got a variable and one doesn't. So those things cannot be added. So what I'm going to do is I'm going to first use commutative property and change the order that two of my terms are in. So I'm going to say 7 plus 5 plus g. And I'm going to leave my grouping symbols the way they were. Now I've just used commutative property to regroup this particular expression. Now 7 plus 5 is something that I can do. 7 plus 5 gets me 12. And so my simplified version of this particular expression, 7 plus g plus 5, when I simplify it, is going to be a lot easier, 12 plus g. So this one is equal to this one. And so I've manipulated this to make it simpler. Here's another one. Why don't you guys pause the video for a moment and give it a try on your own. Okay, so if you were looking at this problem, you notice that we've got m times 11, and we've also got times m. So what I'm going to do on this one is, once again, I'm going to use commutative property to change things around a little bit. I'm going to use commutative property, and so that is going to let me move the 11 to the front, and I'm going to have my m and my 11 trade places. And I've still got my m over here. I'm also going to use the associative property and change where my parentheses are. So I'm going to still have 11 times m, but instead of having the parentheses right here, I'm going to move my parentheses so it's around the two m's. And I know I'm allowed to do this because everything's being multiplied. So associative property says I can change where my parentheses are if everything's being multiplied. So if I do 11 times m, well, m times m can actually be written as m squared, or m to the second power, because that's what m to the second power would mean, would be m times m. And m, or 11 times m, could just be written as 11 times m squared. And there's my simplified version of our original expression. Okay, one final problem. Why don't you go ahead and pause the video and try and solve this one on your own before I go over it. Okay, so once again, we can use some of our properties to help change this expression to something simpler. The thing I notice is that my D and 8 cannot be combined. So I'm going to use commutative property and switch the order that the D and the 8 are in. I'm also going to use associative property to group the 6 and the 8 together because they can be added. 6 plus 8 is going to get me 14. And I have plus D. Those can't be added, so this is as simple as I can get. And now I have my simplified expression. My 14 plus D is the same as my original expression, 6 plus D plus 8. Okay, so that's using our properties to help us simplify expressions. Hope this was good for you, and I look forward to making another video for you in the next couple of days. You guys have a great day.